There has always been a need to send messages from one place to another far away by the quickest impossible method. In the past, drums were beaten to inform of impending dangers, flags were waved to send messages, and at night, flashes of light were utilized for this purpose. In the 19th century, we began to truly understand electromagnetic theory. According to this theory, light and what we now know as radio waves are the same in nature, that is, electric and magnetic field mutually through space, only the frequencies are different. Man learned to deals with the production utilize radio waves for sending messages across the global. The science which deals with the production and proper usage of different frequencies of radio waves for sending sound and visual information is known as telecommunication. In the following section, we shall describe some telecommunication devices. The discovery of electromagnetic waves in the second half of the 19th century helped in a new era of relaying messages from one place to another using these waves. Electromagnetic waves travel at a speed of meters per second. This is called telecommunication. In the following section, we shall describe same telecommunication devices. The electric telegraphy is a device for sending and receiving messages between two distant areas by an electric current flowing through a wire connecting the two areas is its simplest form. An electric telegraph consists of an electric battery connected through a tapping key called the sender to an electric buzzer called the receiver as shown in figure 18.9. Only one wire is needed between the sender and the receiver as the circuit is completed by connected their other ends to the earth, which being moist a few feet below the surface acts as a good conductor. When the tapping key is pressed, the receiver produces a buzzing sound. The buzzer consists of an electromagnetic connected through a movable iron bar which is held against a contact point by a light spring. When tapping key is pressed, a current flows through the coil of the electromagnetic and the bar is attracted towards the electromagnetic. This breaks the circuit between the bar and the contact point. The current stops flowing and the bar is no longer attracted. The spring then pulls the bar back to the contact point and the current again flows. Thus, by pressing the tapping key, the iron vibrates, producing a buzzing sound. The interval between two buzzing sounds can be controlled by the interval between pressing the tapping key. A short interval is called a dot and a long interval is called a dash. By using internal Morse code, messages can be sent from one place to another distant place. In telegraphy, a message can be sent and received at the other end of a telegraphy network by experts who know the international Morse code very well. This mode of communication is also slow and time consuming, thus, there was a need to have such a device by which speech could be transported over a long distance directly from the speaker to the listener. The telephone, which sends sound to a distant place, is this appliance that fulfills this need. This is based on the same principle as that of the telegraph, that is sending and receiving messages between two distant places by an electric current flowing through the wires connecting two places. In the telephone system invented by Graham Bell in 1876, a carbon microphone replaces the tapping key and a magnetic earphone takes the place of the buzzer. A simple circuit diagram is shown in figure 18.10. The carbon microphone has a thin metal plate called a diaphragm suspended in front of a packing of carbon granules. When these granules are in a compressed state, the air space or intergranular distance decreases, and so the resistance offered by the layer of carbon granules to the flow of current decreases. More current flows when the granules are in the compressed state than when the distance between the granules is relatively large. If someone speaks in front of a microphone, the compression and rarefaction that constitute a sound wave cause the diaphragm to vibrate. These vibrations increase or decrease the pressure on the carbon granules very rapidly. Since the granules are part of the circuit, the current fluctuates in harmony with the sound waves. On the other side, the magnetic earphone has a thin steel plate suspended in front of an electromagnetic. When the current in the circuit fluctuates, the field of the electromagnetic changes accordingly. The steel plate therefore experiences fluctuating force of attracting and vibrates in the same fashion as the current in the circuit changes. Sound waves are converted into electrical fluctuations by the microphone at one end, and the electrical fluctuations are converted into sound waves by the earphone at the other end. It may be pointed out that two wires are used for telephones, whereas in telegraphy one wire carries the current while the earth connections complete the circuit. The reason is that the earth connections, if also made in telephone network, would cause so much noise and distortion in the original sound that the message would become unintelligible. The above presentation is in fact a simple illustration of the basic principle of a telephone. Modern telephone circuits are, however, much more complicated nowadays. Scientists have developed telephone systems using optical fibers instead of ordinary copper wires. This has improved very much the quality of sound. Sound waves are converted into electrical fluctuation, which in turn are changed into light pulses with the help of transducer, a device that converts vibration of one quality into another. Example, electrical variations into light pulses. These light pulses travel through optical fibers which are as thin as hair. When the receiving and the light pulses are changed back into electrical variations by another transducer and then back into the sound waves.